Hello, welcome to today's webinar, Choosing the Right Instrument for Your Needs. Presenting today is Mark Gunlock, a solution architect at X-Rite Pantone. I'm Robert Grotans, the Global Technical Marketing Manager, and I'll be moderating today's webinar. If at any time during this webinar you have any questions, please feel free to submit your questions using the form on the page. We will do our best to respond to you as soon as we can after the webinar to get you an answer to your question. Also, after the webinar, we will send out a recording so you can review the webinar at your convenience. So with that, I'll turn it over to Mark to get things started.
Great, thanks, Robert. All right, so let's get right into it on how to choose the right instrument to fit your needs. There are a ton of options out there for measuring color and print, and each of these devices are optimized for specific uses. You wouldn't buy a sports car to haul a boat, and you wouldn't expect a four-wheel drive to perform well on a racetrack. The best instrument is not just determined by price, it's determined by how well it suits your specific needs. Let's take a look at those needs and the instruments that meet those needs. Let's start with densitometers. They've been used for years. They're really good at detecting if the color appears to be a cyan, magenta, yellow, or black ink, and how dark that ink appears in density. The higher the density means that you have a higher ink film thickness. Ink film thickness is a primary control of color on the press. However, keep in mind, it won't tell you the color or the LAB of that ink. So for example, if the ink gets contaminated, say from dirt on the press, other colorants getting into it, being used for a long time, just picking up a contamination, you can hit the same target density, but the color will be wrong. So some entry-level densitometers like the Exact Basic will provide the measurements of density of the inks at 100% solid ink coverage, and the tint values or dot area or dot gain, also known as TVI or tone value increase. More advanced densitometers like the Exact Plus are going to provide additional metrics such as red, green, and blue overprint trap values, and possibly additional functions like print contrast, hue error, grayness of inks. In addition to everything that a densitometer does, a spectrophotometer will also provide a lot of detailed color information. It can compare the color of the printed ink to the LAB target values to inform the operator of the color difference, also known as delta E. Print buyers care if their brand spot colors are right. They'll often specify what delta E they will accept. Also, modern print standards do not specify target density values for CMYK inks. They only specify the target LAB values. Some print standards also require that you measure the color of the overprints and the gray balance patches. Density is still used for process control, but your goal is to match the LAB targets as close as possible. Then document the density that is required to achieve that on your press, ink, and substrate combination. The Exact Advanced also includes options like paper whiteness and brightness and ink opacity, along with color metamerism. All of these metrics can be used to quantify the color that the viewer will see on the print piece. Some other considerations for your instrument selection will include, let's say, the number of samples that you need to measure and how the data is presented. The best press control is achieved when the operator knows exactly what the press is doing for all of the ink colors, and on an offset press, they need to know what each ink key is doing across the width of that press. That can include any of the metrics that we just discussed, and that is a lot of measurements. The Exact can be mated to a manual Exact scan device as an inexpensive way to measure a strip of color patches into supporting software. This can be especially useful for smaller strips used in flexo printing. For more automation, the exact can be placed in the auto scan track using a laser sight to line up the patches across the sheet up to 40 inches wide. And for the highest level of productivity, an IntelliTrax 2 has a look-ahead camera that will find the color patches in the color bar without user assistance. All these systems here are intended to help the operator measure in more patches faster to get good feedback on how they're printing. And the solutions like the IntelliTrax, you can see the screen here, they can, when used in an offset environment, you can see exactly the performance of each of the inks in each of the keys across the press to be able to respond quickly to make adjustments at the press console. So all the instruments and the options we've discussed so far are intended for ink and print production. They're built to take the abuse of the production environment and are expected to be used all day long. There are also instruments that are designed for prepress. These are ideal for measuring in very large numbers of patches, sometimes into the thousands. These special charts are used for calibrating press curves for plate production, or for periodic calibrating and profiling of inkjet printers to simulate production printing conditions. These are the sports cars of the instrument world. They're fast and nimble, but they're not intended for the rigors of production environments. Let's take a look at how these instruments work. All these instruments have a similar type of measurement geometry. That is the relationship between the light source and the angle that reads the reflected light. These are known as 45-0 instruments. The first number represents where the light is coming from, and the second is the measurement receiver angle. This configuration mimics the way that we should view print in a viewing booth. To analyze the color, the received light is then filtered into incremental parts of the full visible spectrum. So by recording the reflected light energy at intervals across the spectrum, a spectrophotometer can, in essence, see how much color there is at each wavelength. So in this example, when we measure this red, each filter results in a recorded number. When plotted against the visible spectrum, we can see that there's a lot of energy reflected in the yellow, orange, and red regions of visible light. This is the fingerprint of this color. Every color has its own distinct fingerprint. The very best match to a color will result in the closest match in these curves. In 2009, ISO 3664 and 13655 were updated to provide better agreement between the user's visual color observations and the differences reported by instruments. Instruments manufactured before 2009 did not meet these requirements. Let's take a look at why that matters so much. So in 2009, ISO 13655 introduced the M modes. These describe some of the different measurement conditions. In North American print production, the two that have the most importance are the M0 and M1. Think of M0 as simply a legacy condition. Before 2009, some of the specifics were not well defined, and each manufacturer did things a little bit differently. The new M1 mode specified requirements including how much UV must be included in the light. This was very important when measuring many of the paper stocks that include optical brighteners. These are being used more and more in production. By the way, M2 is just a new name for what is also called UV cut and was sometimes used for digital printers. It simply filters out all of the reflected UV light. And M3 is not commonly used in North America, but it's used for some special cases and more commonly used in Europe. So let's take a look at what happens with these filters and the optical brighteners. If the substrate you're printing on has no optical brighteners, then it really doesn't matter if you use the M1 or M0 filter. Many packaging materials don't have brighteners. As you can see, the LAB numbers will be the same for this paper, for each of these different M modes. And it'll look the same in the viewing booth under the old style Z50 lamps before 2009, or the new style lamps, or with lamps that have a UV filter placed over them. Here we see a graph that shows the light energy is amplified in the blue range. This is what happens with optical brighteners. This is how they make paper look brighter. So if you're printing on a paper with optical brighteners, then your choice does matter. You can see the LAB values are different for each of the M modes. The M1 is intended to match the current viewing booth standards. In viewing booths with the new ISO 3664 lamps, shown here in the middle, the paper with optical brighteners will look slightly brighter and bluer. In these cases, it is important that you match the M mode to the specified print standard or the customer specified M mode. So a little bit more about the industry standards. There's, again, we talked about the 13655. There's also ISO 12647, which defines some specific print industry targets. Standards are important, and if you vary from the standards, your results will vary. If you don't match the specified standards, you may produce work that you think is acceptable, but then it gets rejected. So we want to make sure that all of our instruments and software are set up correctly. Now, while M1 mode is the preferred, and moving forward, that is, we're going to start seeing more and more M1. M0 is acceptable, and currently most are still doing M0. But just be aware that you may start to see more acceptance of M1, and again, that aligns better with what we're seeing in our viewing booths. G50 2° is a critical setting within your software. In the past, some people have used D65 or they've used 10°. Those are not part of the print industry standards, and you need to align it with the D50 2°, which pretty much across the board everybody's moving towards. And lastly, for looking at the difference of color, we want to use a delta E of 2000. Now that's a whole topic unto its own. We'll talk about that in another session, but just know that this is now part of the ISO standards, and these settings that are described here need to be in all of your applications and your hardware. Now there's some special cases out there for measurement that are particularly challenging. Printing directly on foils or metallic surfaces without an opaque white backer behind the colored inks is a particular challenge. This is due to the specular highlight, where the surface reflects a lot of light in a very directional effect. This requires a special instrument to capture this color and consider it with or without that specular highlight. This is what it looks like when light is reflecting off of a metallized material. You see this really intense specular highlight. Now, the 045 instrument is unable to see this color correctly due to the fact that most of the light that hits the surface at 45° will reflect in the opposite angle and not be captured by the optics of the instrument. So we need a sphere instrument. This is called a D8 geometry instrument. The D means diffuse light. A baffle bounces the light off of the white walls of the inside of a sphere. 8° is the angle of the sample port. Spin, S-P-I-N, allows for the measurement to include the specular highlight or gloss in the measurement. Specs allows the specular component to escape or be excluded from the measurement. At this time, in the print industry, there are no ISO standards for measuring under these types of conditions. There are, however, some developing best practices, and in some cases, the brand owners may provide specific requirements for matching colors with a sphere spectrophotometer. Last time I'd like to touch on is making sure you're getting the right measurements. So you want to make sure you're following the guidelines for proper care and maintenance of your instrument. So an option is monthly profiling. This is a tool called Net Profiler, and it'll perform a more robust calibration of the instrument with a series of colored tiles, and it will validate the results. If it's unable to calibrate the instrument, it'll provide an alert to advise you that you need to send it in for service. There's also the annual recertification. This is where the instrument is sent back to the factory for an even more extensive testing and certification process on a regular annual basis. You also want to make sure you keep the instrument clean and follow the manufacturer's guidelines for the cleaning process. And avoid getting dust in the instrument or on the calibration tiles or on the measured samples. So that is all that I have right now. Robert, I'm going to hand it off to you.
Great. Thank you, Mark. Yeah, so again, this is all we have time for today, but if you have any questions at all, please feel free to submit a question through the form that you'll see to the left of this video. We will do our best to respond to any questions we receive as soon as possible. So again, thanks everyone for your time, and we'll see you next time as we continue our series.